Okay, so this video is going to talk about overlapping triangles. That's going to be exactly like what you think. Two triangles that are overlapping. They share something. They're going to share a side, they're going to share an angle, or they're going to share both a side and an angle. So we're going to use that in here to start thinking about more flow proofs and proving that two triangles are congruent, knowing now everything that we know. Okay, so here are some strategies for overlapping triangles. Redrawing the triangle separately, yet labeling the triangle or those individual triangles as the same as the original drawing. Color code or mark all given information. I like to use two different color highlighters to highlight the two different triangles. Use another color pen to label the congruence you need to establish or prove. Or use an index card or something else to cover up the distracting parts of the picture. I think the highlighter works the best for me, but you might find something else that works better for you. Okay, so let's jump right in. With example 1, I know that triangle BFC is isosceles with angle F as the vertex, and that DF and EF are congruent. So let's go ahead and mark that. We know that. Okay, so let's go ahead and start with our flow proof. So triangle BFC is isosceles, and that was given. Okay, from there, I know that these are congruent, right? By definition of isosceles triangle, we know if we have an isosceles triangle, the two sides that make up the vertex have to be congruent. So that tells me that BF is congruent to FC, and that's by the definition of isosceles triangle. So we had to use this to get to here. Okay, now we know that since BF and FC are congruent, that by the isosceles triangle theorem, that this angle has to be congruent to this angle. So I'm going to go ahead and mark that up. So angle FBC is congruent to angle FCB, and that's by the isosceles triangle theorem. So we had to use this guy to get here. Okay, so now that I know that, let's start with something else that we know. We know that DF is congruent to EF, and that was given to us. Now, I know that DF, so let's see here. If I look at DF and FC, that equals the whole DC. Now keep in mind, what we're trying to do is prove that triangle BDC, so this triangle here, is congruent to this triangle here. Okay, so we're trying to prove the red triangle is congruent to the purple triangle. So DF, all right, we know, let's go ahead off to the side and write, all right, that DF plus FC is equal to DC. And we know that BF plus FE is equal to BE, and that's by the segment addition postulate. Okay, so by using that idea and knowing about these other things, such as BF is equal to FC and DF is equal to EF, we can say that, let's just go ahead and cross this off real quick. Using those facts and the segment addition postulate here, I can say that DC is congruent to EB by substitution. Okay, so that took this given statement, that took this thing here, and that took this thing here. So I had to use three things to prove that. Okay, so now I can look here and say, all right, now I'm able to prove, because I know that DC is congruent to BE, and we also know off to the side, I'll write it in red, that BC is congruent to BC by the reflexive property of congruency, okay? So now I know that triangle, so we know that this is congruent to itself. This thing here is congruent to this one here. Okay, we have an angle right here on both of them, and then we have this piece on the bottom. So by side, angle, side, I have proved these two triangles to be congruent. So triangle BDC is congruent to triangle CEB by side, angle, side. Now, since I'm using three things, I have to make sure I have three things. Well, here's the side I used, here's the angle I used, and then here's the other side that I used. Okay, so when you're proving something by side, angle, side, I better have three arrows feeding into it. Okay, given what we've known and what we've practiced so far, go ahead and take a minute and try to do this flow proof on your own. Okay, so given some information, I know that AD, oops, let's use blue. So AD is congruent to ED. I have that angle 1 is congruent to angle 3, and angle 4 is congruent to angle 5. Okay, and I want to prove that triangle ADB, so this guy right here, is congruent to EDC, so this guy here. So I want to prove that ADB is congruent to this guy. So let's go ahead and mark those in. I want this guy here to be congruent to this guy here. Now hopefully that helps a little bit. So I definitely know that I need this angle and this angle. That's going to help me out. I need something about these two, and we already know that these are congruent. So I really just need to focus on this part of 1 and 2, and 2 and 3. Okay, so I know I'm going to start off with what I'm given. Oopsies, not AB. AD is congruent to ED, and that's because it was given. Okay, I also know that angle 1 is congruent to angle 3 because that was given. I know by looking at this, right, what do we know about angle 2? Well, we know that angle 2 is congruent to angle 2 by the reflexive property of congruency. Okay, so now let's take a minute and think. Okay, so if I add up angle 1 and angle 2, well, that gives me this whole angle here. And if I add up angle 2 and angle 3, well, that gives me this whole angle here. So I know that angle 1 plus angle 2 equals, we'll say, the measure of angle ADB. And I know that the measure of angle 2 plus the measure of angle 3 equals the measure of angle EDC. And that's by the angle addition postulate. Okay, so now if I use the pieces of information that I know here, okay, I can see, especially right here, right? All of this information helps me to see that angle 2 plus, so measure of angle 2 plus the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Again, we can look at that here because of this piece of information here. Okay, so that's again the, the angle addition postulate. So this guy took me there, this guy took me here, okay? Now we know that angle ADB is congruent to angle EDC, okay? And that's because of substitution. Okay, and that's because this guy over here and this guy here fed into that. So last but not least, okay, I now see that I have proven this angle is congruent to this angle. All right, I know that AD is congruent to ED. The last thing I need to make sure I include is that angle 4 is congruent to angle 5 because that was given to us. So now I have angle, side, angle. So triangle ADB is congruent to triangle EDC by angle, side, angle. And I got there by this angle here, this side here, and this angle here. Okay, so again, I had my angle 5 and 4 right here, my side AD and my side DE right here, and then this angle here of ADB, and EDC right here. So angle, side, angle, angle, side, angle.